introduce Mr. Raji R Panicker. Mr. Panicker is the General Manager of Engineering at Navi Mumbai International Airport Private Limited, Adani Group, who is an MEP expert around 25 years of professional experience. Raji has led projects like Mumbai International Terminal 1 and 2, Navi Mumbai International Airport. He delivered complex projects effectively and recognized for authority in MEP design and sustainability. Today, Mr. Panicker will talk on Introduction to Sustainable HVAC. So, without any further delay, let's welcome Mr. Panicker.
Today we will explore various aspects of energy efficiency, water conservation and HVAC technologies that contribute to sustainable building design. The agenda for today includes building envelope optimization, climate analysis, energy efficiency measures and water efficiency. Now, the intent of this presentation is to share my experience on various projects, what I have done, and how it is implemented, and basically what are the energy saving measures considered. There may be individuals who will differ a bit based on the savings because it varies on project to project. So, without any delay, I'll go to the next slide. Basically, this is it's an energy efficiency for building envelope, which is the skin. Now, basically, when we do a building envelope, majorly we start from the wherever the high heat gain, majorly it's from the roof. You should be having a higher insulating value roof. And facade is the prime part. If it's a DGU, then you need to have a lower U and SHGC value. And basically, what happens, this depends on the orientation of the building. So let's say if you are having a south side facing where you have a high amount of heat gain, so you can have a south side glass which is having a lower U value and SHGC, vis-a-vis a north which has a lower radiation level. So in that manner, you can always play around with the U value and SHGC of the facade. So you can have a varying aspects around the envelope. And one more aspect on a facade design basically is ideally we have a vertical facade installed on a building, but if it is tilted to a 5-degree tilt towards the higher radiate heat where it is falling, where you have a higher amount of heat gain, you can reduce the cooling load. And the next aspect is the shading. Shading always is predominantly used for climate based on the climate analysis, but shading depends on the elevation. I mean, architects has to agree with it whether what kind of a shading they would need to go in for. It can be a static shading or it can be a dynamic shading. And next is the building orientation. On the right hand side, you can see this is basically an output of an ecotech I have been using long time back. Now it is obsolete. People are using Grasshopper, Revit and all for analysis. But this is a very faster tool where you put a building geometry and it will rotate the building based on the climate and it will give you the orientation, best orientation which can be used. But yeah, certainly this depends on the plot layout and how your plot is oriented. So this may be one of the factor which can be considered. So coming to the cooling load now, earlier we used to do cooling load in CLTD or HAP 5.1 whatever trace. But now what has happened, like we have a very good software which is already on board. Like you can use Trace 3D, you can use HAP 6.2, IESV. Now the benefit of this is basically you can do a lot of parametric study with this. You can play around with the envelope factors, or you can play around with the type of systems or strategies what you want to implement. The standards what you can follow is 90.1, Green Guide is there, 189.1 ASHRAE is there, ECBC. All this gives a base case of what you want to achieve from below to a proposed scenario. This basically is climate analysis, what is done initially in a project phase. So this gives the thermodynamics of the air properties. So this is a climate concept room. It's readily available. Anybody can download it, and you can download the EPV file from Energy Plus site. And once you upload that file into the software, it gives you a psychometric chart based on the strategies of the system, what you can do to optimize the energy and lower the cooling load of a building. So I've done this for a Mumbai, and you can see that 82%. It's not legit fine. There's 82% of the time it is cooling and dehumidification. But there are other strategies which can be adopted, like solar sun shading. So this is one of the method. But here you won't get indirect evaporative cooling. That is one additional features which needs to be introduced, but that can be done on a separate analysis. Yeah. So coming to the equipment, what do you do on an equipment when it comes to energy efficiency? Basically, chiller is the largest consuming portion on a building, and you have to select a better chiller, whether it's a BFD or a non-BFD drive. But selecting a BFD drive, I mean, this is I've been using HT BFD, which is The recent building I'm doing, it's not an LT BFD, it's an ST BFD. So 11 kV, and the benefit of that is a study was done. I did an analysis based on the cooling load, load profile, and then a parametric study was done based on which it was observed that for a hot and humid zone, I mean, primarily the calculation needs to be, the data needs to be there from all the vendors in place. So you do a comparative study, which chiller is much more efficient with a VFD drive. So this actually represent the operating hours on 7 degree. This is the condenser water entering temperature from the cooling tower. And if I'm comparing this with a variable frequency drive chiller, on the left hand side is the 7 degree Fahrenheit operating hours. So it varies from look 18 degree to 33 degree. This is in Fahrenheit basically. So if you look at the savings, what we can achieve with the VFD versus a non-VFD, a VFD will be giving you around 2.4 to 6.7% of a saving with a 7 degree Fahrenheit approach. But if you are having a cooling tower with a 5 degree Fahrenheit approach that is a larger heat exchanger, the saving drastically improves because there's a shift from the operating hours, which can be from 10% to 12%. This varies with chiller to chiller. So this, I mean, everybody might be aware of this primary, secondary, and primary pumping. Mostly primary, secondary we use it when there are multiple zones, and primary variable pumping can be used when it's a single zone. But I have only implemented this on a very small scale project, not on a very large scale. I haven't seen anything on a very large scale project. Maybe there are some of the project which might have been there, but I was unable to see whether how efficient it is. I mean, this is certainly good, used in data centers and all. And the primary, secondary versus primary variable, the benefit you get is basically 8% at full load, and at part load, the based on the pump load, the efficiency, the pump energy will improve drastically. This is one of the tool I've been using. This is my PLV from Trace. It's a train site. So this is used for condenser water optimization. So let's say, I mean, this chart actually reflects a base case. If you look on the right hand side, it is basically 3 GPM. Let's say you're designing your condenser for 3 GPM per ton. Now, if you use this tool, basically what it does is it calculates all the GPM factor at what GPM you're having a system saving. So if you look at the slide, and at 2 GPM and it's a 1.75 GPM, your system saving is around 5.6%. Now, the benefit, I mean, the way it has to be done is basically this is not a dynamic operation like you modulate from 3 to 1.5. It is a static operation. You should be using a double regulating valve. So let's say I adjust my DRV to 3 GPM per ton, and with a variable frequency drive, I need to readjust it to 2 GPM per ton. So that is it's a fixed load, because in varying it won't serve any purpose. You have to keep it at a fixed load, and related to all the condenser efficiency and all that has to be taken from the condenser performance chart, which is readily available from the vendor, and you can use a linear equation to calculate this. This is like there has been a lot of noise on EC fans usage and its benefit. So we thought of exploring this, and what we have been doing for projects that the centrifugal versus EC fan. We did an analysis based on the curve and the load profile. This is at a peak performance, wherein what we observed that the saving can be achieved up to 14%. But when your system operates at a part load condition, you can achieve still more higher figures, which we haven't done it because 14% is fine because that is the operational criteria or the benefit what we get. So all this thing what contributes to the lead USGBC lead version 4. You can get benefit out of this in terms of optimized energy performance. So this is related. I mean, apart from energy saving, there are factors like water efficiency also play a major role. As you are aware that there's always a dearth for water resource, and the water should be judiciously used by treating, recovering, and all. So for a cooling tower, you can use a drift eliminator, to reduce the droplet which goes out through a drift. You can have a water treatment plant. It can be a softening plant or filtration, and to increase the COC level and all, which reduces the blowdown in turn. And for a water recovery and reuse, this one reuse of condensate has been done for Terminal 2. That is one of the largest, I presume. I don't know any other projects has done that on that plan, and we recover almost around 80 to 60,000 liters of water per day for reuse. The reuse of makeup for the makeup water is very marginal, hardly 2%. But that is not the fact. The fact remains why to waste the condensate down the drain. Instead, you can use it for some other purpose. It can be used for cooling tower, you can use it for pre-cooling or anything. The next is the recycle treated water. So this is basically we've been using recycle treated water for a makeup or water treatment. That's it from my end. I mean, if there's any queries, I'm ready to answer it. Thank you.
Thank you, Mr. Panicker, for
Yeah.
talking about sustainable HVAC.